Hi guys, good day. Lever here from Bright Young Brains. In this video, we're going through the entire grade 12 mathematics 2024 paper 1 exam. However, just like what I did with the paper 2, I'm going to go through it from the back to the front. So meaning I will be starting with the last question, working my way backwards to the first one. Question 12 says that a company generates a 4-character code using the 26 letters of the alphabet and the 10 digits from 0 to 9. And then it says here, the code is in the form letter, digit, letter, digit. Okay, and then they said there, determine how many codes can be formed if letters and digits may be repeated. Okay, so this one is a straightforward question. It's a straightforward 2-mark question. We're not even going to do a lot of thinking here. Our code has 4 placeholders, right? So this has to be a letter and then a digit, a letter and then a digit. They specifically told us that digits here may be repeated. How many different codes can be formed if letters and digits may be repeated? So what you need to think of is, in this first position, right, you have an option of 26 letters. In this second position, you have an option of 10 digits. And then you have an option of 26 letters again. And then you have an option of 10 digits as well. So this multiplied together, this is going to be your final answer, of which, if you think about it, this is going to give us 260 times 260. You would think that I would have a calculator while going through this exam, but fun enough, I misplaced my calculator. But the answer here, this is what you would put there as your final answer. The answer here is 67,600. Moving on, the next question says, determine how many different codes can be formed if the letters A, F, I, Q, U, and V may not be used. The next parameter says the code may not start with a W or a Z. Letters or digits may not be repeated. The code ends with an odd digit. So when you have questions like these, right, you need to make sure that you account for every restriction that they've given, and you do that with the strictest one to more like the more loose one. So in other words, what you're going to do is you have 4 placeholders, right? The code has to have 4 digits. So the first key element of reading all this is that the code ends with an odd digit. So you can already start there, one way or the other. If it ends with an odd digit, remember, an odd digit means that it can either end with either 0, 2, 4, 6, or 8. There's only 1, 2, 3, 4, 5 options in total. So in the end here, you only have 5 options in total. That's the first thing that you know. Now what you can already do for yourself is that, since you know that there has to be a digit here and a digit over there, if one number is used up over here, right, automatically here you will only have 9 options, because remember they said you may not have any letters or digits repeating. So you have 5 options here, right? This is the bigger restriction. The code has to end with an odd digit, and that can either be 0, 4, 2, 6, or 8. So once you put a number here, you only have 9 options for this placeholder here. Secondly, they said that the code may not start with W or Z. So what that means is, firstly, in this first position, right, originally you have 26 options. So this bullet point here automatically tells us we will be down to 24. But then this next bullet point here, we also cannot use D, F, I, Q, U, or V. So that's 1, 2, 3, 4, 5, 6, 7, 8 letters that cannot be in this first position over here. So we cannot have a total of 8 letters in this position. So it means that the number of options that we have in this position is 18. There's a total of 18 options that we can put in the first position over here, because remember we have 26 in total. We removed 2 and then we removed 6 more, you see, so that will give us a total of 18 options for this first position. However, in this position over here, you need to remember that when one letter is used up over here, don't make the mistake of thinking that you have 17 options here. Don't make the mistake of doing that, because remember W and Z cannot be used as the first letter. However, W and Z could possibly be here. So what you need to think to yourself is that you have 26 letters in total, right? Out of those 26 letters, 6 are definitely restricted, right? 6 of them are restricted completely. You can never use 6 of the letters. So meaning originally you would have about 20 letters to choose from. But then of these 20 letters, logically speaking, one of them has gone here already. One of these 20 letters has been used up here. Or rather, if you think of it logically, of these 20 letters, right, that you could potentially use, 2 of them is, one is a W, one is a Z, of which a Z was never used here, a W was never used here. What was used here is any other letter that we don't know, right? So meaning that in this particular position, you're only going to have 19 options. I'll repeat, you have 20 options to choose from overall. Of these 20 options, right, we know that a W or a Z is included in these 20 options. However, a W and a Z was not used here, which is okay, meaning that of the 20 letters that we can choose from, W or Z was not used, and of these 20 letters, 1 letter was used logically. So you only have 19 options for this position over here. So your total number of codes is going to be 19 times 9, 18 times 9 times 19 times 5, right? Let's see what that gives us in our calculator. So let's just put that in the calculator and then we'll get an answer. So if you need to recap on the logic that we used here, you can simply just rewind, listen to what was said again, and then you can then just carry on from there. So our final answer here, it is going to be, let's see here, 18 times 18 times 9, 18 times 9 times 19 times 5. This is going to give us a total of 15,390 codes. Yeah, that's quite a lot, but it's significantly lower than the total number of codes we have. Moving on to the next question, that is 12.3. 12.3 says the following. It says there, the company wishes to increase the number of 4 character codes formed in question 12.2 by allowing letters D, F, I, Q, U, and V to be used. Calculate the percentage increase in the number of different codes that can now be used. The percentage increase in the number of codes that can now be used. So logically speaking, all they are asking you to do here is, if these letters are used, how many codes will you now be able to make? And then you just compare the difference between this value and the new value that you would have gotten. So for 12.3, right, what we can do for ourselves, again, we have 4 positions, right? And we said firstly the code still has to end with the odd number, so there are 5 options here. Once one number is used here, there are 9 options here. And then for the letters, logically we said that we have 26 to choose from, right? But then in this first position, 2 of them cannot be used, so we will only have 24 options here. You see, we have 24 options here, but then the moment one letter is put in here we only have 23 options, you see. So the total number of codes that can be formed here, well, let's see what we get in our calculator. We're seeing there 24 times 9, and then times 23, and then multiply that by 5. Okay, so this is giving us a total of 24,840 codes. So if you're going to work out the percentage increase, what you need to do is you need to take 24,840, you subtract the 15,390. Let's see what that gives us first before we can work out a percentage. So minus 15,390. So this is telling us that the difference here is 9,450. So you have to take the 9,450 and then you divide it by 15,390, then you times by 100 to get a percentage. The reason why we're dividing by the 15,390 is because the 15,390, that's the original number of codes that we were able to generate, right? So if you're going to work out a percentage increase, you have to be using that value. So 9,460, this is 61.4% of the 15,390. So the percentage increase here, if you round it off to 2 decimal places in your calculator, is just 61.40. Okay, therefore percentage increase, therefore the percentage increase is 61.40%. Yeah, the number of codes increased by 61.40%. Very simple 8-mark question here. Remember, we're starting from the bottom, working our way up. So we have 8 marks here. Let's move on to question number 11. Question number 11 in this 2024 November grade 12 mathematics paper 1 exam that was written a few days ago. We need to work out question 11. It's out of 9, and as we said, we're working our way backwards. So as we work our way backwards, we're just taking it easy, one step at a time. Question 11, let's see. Question 11. The first thing that they're saying there is that a certain number of learners are sitting for examinations in mathematics, tourism, and geography. So this looks like a Venn diagram kind of equation. It just looks like it. Then it says all these learners sit at least one of these examinations. The total number of learners who sit for math is 22, for tourism is 16, geography is 18. 5 learners sit for maths and tourism, but not geography. So the logic with Venn diagram questions is you can just browse through the bullet points and then start drawing, right? So 5 learners sit for maths, tourism, but not geography. Then they said 4 learners sit for maths, geography, but not tourism. 3 learners sit for tourism and geography, but not maths. 6 learners sit for only tourism. Draw a Venn diagram to represent all the learners sitting for these examinations. 3 marks. So stingy. But I understand why it's 3 marks, because drawing Venn diagrams is one of the easiest things you'll ever have to do. Remember, you've been drawing Venn diagrams since grade 10. So a Venn diagram is something that you definitely need to be able to draw. So you have maths, you have tourism, and then geography. So the key element of all Venn diagram questions is the total of each category, right? So for example, they said that you have a total of, we don't know how many learners in total actually, they haven't told us. But then they said all these learners sit at least one of these examinations. So they said the total number of learners who sit for maths is 22. So what that means is this section, the number that goes here and that one and that one and that one, they all have to add up to 22, right? And then for tourism, all the numbers that are going to go into the tourism section, here, 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 and there, they have to add up to 16. And then for geography, we have a total of 18 learners. What that means is this, that, and this, and that, they all have to add up to 18. And then they said the total number of learners, it says 5 learners sit for maths and tourism, but not geography. So when they say 5 learners sit for maths and tourism, but not geography, what that means is, you see, anything where geography is involved, what you need to consider is that, logically speaking, if they said 5 learners sit for maths and tourism but not geography, then you have to put the number 5 in here. You see, because this is the section where maths interacts with tourism, but then it's excluding the geometry section altogether. And then it says here 4 learners sit for maths and geography but not tourism. So 4 have maths and geography but not tourism. So 4 has to be here, because that's where maths and geography meet. Then it says 3 learners sit for tourism and geography but not maths. So that's, no, 3 learners sit for tourism and geography but not maths. So where tourism and geography meet, excluding the maths, that's 3. And then the key information here, it says 6 learners sit for only tourism. So in the section where you have only tourism, you have to put a 6 there. So since this is the circle that has more numbers, you can complete this one first, because 16, you have to just remove the 6, the 3, and the 5 to get the number here, because all these numbers here you have to add up to 16, you see. So first and foremost, 16 minus 6 is 10, minus 5 is 5, minus 3, you have 2. So only 2 learners do all 3. And then once you have these 3 here for maths, you can also just say 22 minus 2, that's 20, minus 5, that's 15, minus 4, that's 11. And then they said here 18 do geography. So 18 minus 3 gives you 15, minus 5 gives you 11, minus 2 gives you 9. So you have your Venn diagram. And they said here, the important piece of information is that all these learners sit for at least one of these examinations. So it means that 0 people sit for none. So that is important. We can easily then work out how many people are in our sample space here. We add up everything. So this is just 22 plus 9, that's going to be 31, plus 3, that's 34, and then plus 6, that's 40. So we have a total of 40 learners that are in this sample space. I hope I didn't make any dumb mistake, you know. Perks and the disadvantages of not using a calculator. Yeah, I know it's strange, but anyways, we can just double check. 16 minus 6 gave us 10, minus 5 gave us, yeah, we're good. Let's move on with the questions. They said we have 3 marks so far, right, for 11.1. They said here, calculate the probability that a learner chosen at random will sit for an examination in at least 2 of the subjects. So the probability that someone chosen at random will sit, keyword here, at least 2. So meaning we have to consider everyone that sits for 2 and more than 2. So these 5 people sit for at least 2, that's maths and tourism. These 4 sit for at least 2, that's maths and geography. These 4 sit for at least 2, that's geography and tourism. These 2 sit for all 3, that's tourism, maths and geography. So these 4 numbers are the ones you have to add up. So that's 5 plus 2 and 3, that's 10, plus 4, that's 14. So you have 14 out of 40 people that at least have 2 subjects. So the probability of that, this is just going to be 7 over 20, you see, and then you can just leave it like that. 11.3, right, says for 4 marks, determine if the events sitting for an examination in maths and sitting for an examination in tourism are independent. Support your answer with necessary calculations. So independent events, you know that the probability of, let's say, M, and the probability of, in this case we're talking about tourism and mathematics, so the probability of M and the probability of T, if it is equal to the probability of M multiplied by the probability of T, then the events will be independent. The events are independent if this formula is balanced. So firstly, let's work out what is the probability of M and T. So meaning the probability of choosing tourism and maths. Tourism and maths, you have 5 and 2, so that's a total of 7 out of the 40, right? 7 people out of 40 have tourism and maths, so this is going to be 7 out of 40. Let's see here. And then the next thing we need to get a value for is the probability of math, right? So the probability of math is technically going to be 22 out of 40. 22 out of 40. And then the probability of tourism, this is going to be 16 out of 40. Okay, so we have to find out if this multiplied by that gives us 7 over 40. So let's work that out. You see, probability of M times the probability of T, this is 22 over 40 times 16 over 40. So let's see what that gives us. So in the calculator, let's put the 16 over 40, or rather let's say 16 times 22. Our numerator will be 352. Our denominator, 40 times 40, so that's like 4 times 4, that's 16, and then 0 and a 0 there. Okay, so this number we obviously need to put it in its simplest form to see if it matches 7 over 40. And so far, who knows? Who knows? Let's see what it gives us. This is giving us 0.22, but as a fraction, let's see if they are the same. And no, they're not. You see, they're not the same, because this one, logically speaking, right, if you break it down into simpler forms, here this can be broken down into 22 over 100, which can then be broken down into 11 over 50. You see, 11 over 50 is not equal to 11 over 50 is not equal to 7 over 40. Therefore, events are not independent. Yeah, they would only have been independent if this value is equal to the value on the right hand side over there. So that's going to give us 4 more marks. So we have banked 8 plus the 9. We can move on with the rest of the exam. Question number 10, it's out of 8 marks. It says here, a cyclist rode from town P and stopped at town T. The speed in kilometers per hour in which this cyclist rode is represented by this equation. So this is the speed that they rode. Take note that it's the first derivative, right? And then it says here, note, speed is the rate of change in distance with respect to time. Yes, that's very correct. The original equation would have been a distance equation in terms of time. Its first derivative is a speed equation. Then it says, calculate the maximum speed that the cyclist reached on this ride. So as always, anytime you get a question that's asking you to get the maximum of anything, the one thing you always have me say is that get an equation of whatever they are talking about, right? And then differentiate that equation and make it equal to 0. So this is already a speed equation. Take note of the fact that it's already a speed equation. So if they want you to calculate the maximum speed, you need to get a specific value of t that you can put into this equation. Now, to get that specific value of t in this speed equation, you have to differentiate this speed equation first. This is going to be negative 6t plus 18. And then you make this differentiated equation equal to 0. You see, the 6t goes to the other side. Divide both sides by 6. Your t is a 3. So this is saying that the maximum speed is achieved where t is a 3. So to get that specific maximum speed, you have to put a 3 in the speed equation. You see, so if you put a 3 in the speed equation, here you have 9, and then 18 times 3. All this is numbers that you're obviously going to put into your calculator, right? So 18 times that by 3, it's giving us 54, and the 9 times 3, that's giving us, with the negative, that's negative 27. So moving on from here, you're gonna say 54 minus the 27. Your final answer there is 27. Yeah, of course, 27 kilometers per hour. This is the maximum speed. Okay, so that, if you check your mark allocation, it's just a 3-mark question, so we shouldn't struggle too much. The next one, however, says calculate the distance between P and T. What a wow! So if you're going to calculate the distance between P and T, you obviously need your distance formula, which is quite an interesting scenario. We need your distance formula. Or do you? Well, logically, if you're going to get your distance formula here, you have to get the original equation. And if you're going to get the original equation here, you at least also need a coordinate that you can put into that original equation. Okay, let's see. Calculate the maximum distance. Oh, no, calculate the distance between P and T. Or rather, let's see the question again. A cyclist rode from P to T. A cyclist rode and stopped at T. Then he says the speed in kilometers at which this cyclist rode is represented by this equation. Okay. Note, speed is the rate of change in distance with respect to time. Yes, calculate the distance between P and T. If you're gonna calculate the distance between P and T, you somewhat need an original equation. And the original equation here would somewhat be a cubic function. Yes, and then that cubic function could easily have had a constant. So this is one of those questions where you can easily be thinking to yourself, do we really have enough information? Just like what I did in the paper 2 exam, as you noticed, there are questions that I was looking at and all I was doing was banking that time based on the mark allocation, if they looked a bit strange or funny or something like that. Mainly because when you look at them for the first time, they just look like it's not going to be a swift question. So what I normally recommend is that you leave space for that question, move on, and only go through it when you're done with the exam. So 10.2 is the first question where we're going to do that, because we definitely need a distance equation, and to get that distance equation we have to get the original equation of S here. That's more like integration, but in grade 12 we can reverse this just by using logic. But for now, I suggest we leave it and come back to it later. Question number 9. Question number 9, it starts off with we have a cubic function over there, yes, and then it says that A, you have point A and point B. These are turning points, so take note of that. The turning points of the graph of f. C is a y-intercept. So we have quite a lot of information here. We just don't have an x-intercept, but it doesn't look like that's going to be difficult to get. 9.1, the first thing that they're asking us is for which values of x is f decreasing. So this is an easy question. If you're going to work out where a graph is decreasing, always try to focus on, firstly, where are your x-intercepts? I mean your x values of your turning points, right? So this is where our x values of our turning points are. Before x is a 1 here, you can see that clearly your x values are increasing. I mean your y values, sorry, your y values are getting higher and higher and higher until here. So from 1 up until 5/2, you can see the y values are decreasing. You see, this is the section where the y values are decreasing. So it's just going to be from 1 up until 5. So your answer, you're going to say x is an element of 1 up until 5/2. Sorry, you're going to use round brackets because specifically at 1 and at 2/5, your graph there is stationary. You see, so where a graph is stationary, it's neither increasing nor decreasing. So that's why the 1 and the 5/2 are not included. 9.2 there says it says write down the values of x. No, write down the x-intercepts of the first derivative. Okay, write down the x-intercepts of the first derivative. Okay, that's quite interesting. The write down the x-intercepts of the first derivative. So what you need to recognize is that the differentiated equation of this graph is going to be a smiling parabola. Now, what you know about the x-intercepts of a first derivative, they will always be linked to your x values of your turning points. I'll repeat. The x-intercepts of your first derivative will always be linked to the x values of the turning points. Because remember, a first derivative is a gradient equation. Your y values of that gradient equation will be representing the different gradients on this graph, you see. So this is telling us that where x is a 1, our gradient is a 0 there. So meaning for our first derivative, the y value will be a 0 there, and the y value will also be 0 over here, because this is where a gradient is a 0, this is where a gradient is a 0, because those are turning points, you see. So where our gradients are zeros, it represents where our y values of our first derivative will be zeros also. So the simple answer here, you're going to say x is equal to 1 or x is equal to 5/2. They're going to give you 2 marks for writing that. Next, it says for which values of x is f concaved up. So being concaved up, all you have to do is you have to focus on where the point of inflection is first. The point of inflection is in the middle of your 2x values of your turning points. You see, the coordinate here is literally the midpoint of these 2 values. So if they're asking where is it concaved up, you always just need to look for the side that is smiling, because one side you can see here it's frowning, the other side here is smiling. You see? So this is the side that's concaved up. So in between 1 and 5/2, let's get that value first. 9.3. This thing is not focusing. Why? So 1 plus 5/2, let's just get the middle of these 2 numbers, right? So that's like the middle of 1 and 5.2 is 1.75. So you can either put the 1 3/4 if you want, or you can put 1.75, or you can write it as a mixed fraction. You see, you can put 7 over 4. You can do it like that. So that's the x value here, you see. So the side that is concaved up, you're going to have to say x is bigger than 7/4. That's the side that's concaved up. That's going to give you your 2 more marks over there. 9.4 says determine the value of k for which this equation will have 3 positive x-intercepts. Okay, that's very interesting. Well, fortunately, this is not a difficult question either, because it's only for 2 marks. If you look at the value of k, right, the value of k is a vertical shift, right? If you look at it nicely, this value of k here, it's a value that moves the graph of f up or down. You see, that's what k is doing to f there. So if you think of it nicely, right, originally the graph of f has 1 negative x-intercept, right? Now they're asking you how many units downwards does this graph have to be moved for it to have 3 positive x-intercepts. So the logic behind that is, firstly, you can actually focus on this x-intercept here first. The reason for focusing on this x-intercept is because it's one of the ways that can help you to track movements going downwards. So if this graph was moved a total of 7 units downwards, right? If the whole image moves 7 units downwards, logically you're going to have a picture that looks like this. This would be going up, and then you would be having a picture that looks like that. This is if the picture was moved 7 downwards. So what we know is here the y value is 8, right? So if it was moved 7 downwards, here this would automatically be 5/2 and 1. You see, so far it will have 1 x-intercept, that's a 0. But then if you move it 1 more unit downwards, it will have 1 x-intercept, and then another one that will be, if you move it 1 more unit downwards, right, it will look like this. You see, it will have 1 x-intercept that's a positive, another one that's a positive, but we want it to have 3 x-intercepts that are positive. So before we carry on, right, you have to consider that the moment it is touching our x-intercept, it has moved a total of 9 units downwards. Once it has moved it has moved a total of 8 units downwards. When it has moved a total of 8 units downwards, you need to consider that the turning point here is 1 coordinate 1 so far. Okay, so if you compare this y value of our turning point and this y value of our turning point, they are only 1 unit apart. So the logic behind that is that once you've moved this graph 8 units downwards, right, you can move it just more than 8 units, it will be having 3 x-intercept. The moment you move it just above 8 units, right, it will be having 1, 2, 3 x-intercept. But then the moment you move it anything more than 8 units, one of your turning points will be on the x-axis, and then the other one will be somewhere there. So what we need to focus on is the fact that the minimum amount of units that this graph needs to be moved downwards is 8, but then the maximum amount of units that it needs to be moved downwards is 9. So your value of k here, right, k has to be, this is how you're going to write it down, your value of k, right, remember k has to be a negative number, so k has to be smaller than -8, but then k has to be bigger than -9, because if k was a -8, it means that the image would have been moved 8 units downwards, it would be touching the x-intercept. But then if you move it just more than 8, it will start to have 3 x-intercepts. But then if you move it more than 9, it will not satisfy the scenario anymore. So k has to be between -8 and -9, because putting a negative number there is what will cause your graph to move downwards. That's a 2-mark question. These are 8 marks that we can safely say we got easily. Let's move on to question number 9. Questions like question 9, these are the types of questions that if you're still struggling with these types of questions, then I highly recommend that you sign up for the online courses on our course website, of which the website there is courses.brightyoungbrains.co.za. The link to that is also in the description. Question number 8 says the following. It says for 2 marks, determine the derivative there. That's 8.1.1. 8.1.1, it's as basic as they come, because it's one of those questions that just don't have any sting, it's just free 2 marks. So to answer this, we're just going to differentiate. Here you have 1 times 3, which is just a 3, because you take exponent times the coefficient, then you remove 1 from the exponent. Then here 2 times -5, that's a -10, and you remove 1 from the exponent. This is your differentiated equation. 8.1.2, right? Without overcomplicating anything, 8.1.2 wants you to get the first derivative if your equation of g of x looks like that. So the one thing that stands out with the equation of g of x is the square root, that means the third here. So we can deal with this very easily, and this also. So with this fraction, the x squared, we can take it up where the 2 is, but the moment you do that, you have to change the exponent to a negative. Anytime you move a value up or down and it passes the division line, its exponent just has to change sign. So if it started off as a negative here, if you move it up, it has to be plus. When you move it down, it would need to go back to a negative. You see, all it does is moving an expression across this division line, it just changes the exponent sign to either a plus or minus, and vice versa. So we have done this so far because we always want to have a coefficient, base, and an exponent for us to differentiate easily. So this we have not yet differentiated, so let's put g of x in front. Anytime you see a third function with a value out here and a value inside here as an exponent, you can always put the value outside under the exponent like that, because now you can differentiate. Differentiating now, you have -2 times 2, which is -4. Remove 1 from the exponent. 7/3 times -1, and then remove 1 from the exponent, right? This is going to give you 4/3, like that, because if you remove 1 from here, you have 4/3. This is your final answer. You can just leave it like that. You're gonna get 4 marks. I'd say the first mark comes from changing this, differentiating this, and then differentiating that. 4 easy marks. 8.2 says we need to determine, or given this expression rather, no, 8.2 is determine the equation of the tangent to this equation for 3 marks if they meet where x is a 1. This is a very, very standard, straightforward question. We need to determine the equation of a tangent to a curve. So remember, anytime you need to get the equation of a tangent to a curve, just remember that the tangent and the curve, they share 2 pieces of information. That is a coordinate at the point of intersection, and it will also be the gradient at the point of intersection. So getting an equation of a tangent, you can start off by writing the equation of a straight line, because that's what a tangent is. It's a straight line. You need to get its equation, you need to get its y-intercept. Oh no, you need to get its gradient, and you need to get its y-intercept. To get a gradient of a tangent, in this situation, our tangent meets our curve where x is a 2. So for us to get the gradient of a tangent, or our tangent here, we need to find out the gradient of this curve where x is a 2. Because where x is a 2, that's where our tangent meets our curve. And that's where our gradient of the curve will be equal to the gradient of the tangent. So let's get the gradient where x is a 2. To get the gradient where x is a 2, we have to use the first derivative, because our first derivative is the one that gives us gradient. So we've differentiated once. In this first derivative, we're going to put 2 where x is, right? And then let's work this out. This is just 9 times 3, 27, 16, 2. This is 11. Is it? Yes, it is. Plus 2, that's 13. So we have a gradient of 13, right? This is our gradient of our tangent. The gradient of our tangent is 13. Now, if you want to get a coordinate that this tangent passes through, you can also use this x value of 2 inside our coordinate equation, because if you throw 2 in here, it's going to give you the y value where x is at 2, which we need to get the full equation of our tangent. So let's put 2 in our original equation. You can have 2 cubed, 4 times 2 squared, and then 2 times 2 plus 3. So this you can just put in the calculator. This is giving us 8, negative 16, 4, 3. This is giving us negative 8, 7, negative 1. This is a coordinate that the graph passes through. So what you can then do is you can say y minus y1 m x minus x1, because in our equation of our tangent, our y value is negative 1, right? So you can put a plus 1 over here. Gradient we have, our x value is a 2. There you go. Simplifying this, you're going to have 1 go to the other side. So you're going to have y is equal to 13x minus 26 minus 1. This is giving you y is equal to 13x minus 27. That's your equation of your tangent to your curve. And we have 3 marks. You can see why they made it a 3-mark question, because this is as basic as it gets with getting an equation of a tangent to a curve. And these are the types of tutorials that are plenty even on this YouTube channel and on the course website. Moving on to the next question. For 8.3, they said determine, or given that equation, you need to determine the first derivative using first principles for 5 marks. That's as basic gets, right? Never find yourself getting these kinds of questions wrong. So let's see. The first thing you're gonna do here is you're gonna write out your equation for first principles. As we know, it's already on our formula sheet. If you forget it, I haven't looked at the formula sheet up until now. I don't need to look at it, but obviously we're trying to make a point here. This is the formula you need. You see, lim h goes to 0, etc. So that whole h goes to 0 portion, you have to write it over and over and over again, you see. So let's see. You're gonna have the lim h goes to 0, fx plus h minus f of x, the whole thing over h. The one thing you'll always hear me say is that, fortunately, this is simple. So where x is in this equation, you can put x plus h there. But then what I normally always suggest is, on your answer sheet, just get an expression for this first before you carry on. So 6, where x is, you're gonna put x plus h, and then simplify this, right? So you're gonna have your x squared plus 2xh, and then plus h squared. Multiply the negative 6 inside, you're gonna have negative 6x squared minus 12xh minus 6h squared. And then that's that, right? So now you can take this and drop it over there. This you can drop it over there. Don't forget the minus. So carrying on, I'm gonna have f prime lim h goes to 0. Here you're gonna put the negative 6x squared minus 12xh minus 6h squared, and then you're gonna have to put a plus 6x squared, because when you drop a minus 6x squared there, it becomes a plus. over h. This always has to cancel out, or else you'd have done something wrong. If you take out a h as a common factor there, you're gonna have 6h here. H goes out as a common factor there. Now the whole limb h goes to 0 comes into effect, right? Because now you have 12x minus 6, and then the h here is technically just going to fall away, and then there's your final answer. Because even if you used normal differentiation, 12 times negative 6 should give you negative 12, and then removing 1 from the exponent should give you 1 there. So you know your answer is definitely correct. 5 easy marks. 8.3. What does 8.3 say there? Or rather 8.3.2. 8.3.2 says determine, or it says write down how you will restrict the domain of f such that the inverse of f is a function. So this is a very, very, very common inverse functions type of a question. You see, they're asking how will you restrict the domain such that the inverse is a function. So what that means is, just as a small tutorial, it's a 1 mark question. So what that means is your graph of f, right, logically it looks like this. You see, now its inverse would have looked like this. No. I think I may have made a mistake here. Yes, the inverse of this graph is the other way around, because if you have a smiling graph, right, its inverse looks like that. But then if you have a frowning graph, right, its inverse looks like this. Okay, yeah, this is much better. So this is what f of x is, and then its inverse would look like that. Now f of x is a function because it passes the vertical line test. The vertical line test is a scenario where you're going to draw a straight line going downwards, right? If it cuts your graph only once, that graph is a function. However, the inverse fails the vertical line test, because if you draw a line going straight downwards, it cuts the graph more than once. So this one is not a function because it fails the vertical line test. This one passes the vertical line test. So even in simple words, that's how you say it. If they ask you why is this graph a function, if it's a function, you'll say it's a function because it passes the vertical line test. If it's not a function, you'll say it's not a function because it fails the vertical line test. Okay, so in this situation, our first derivative, right, fails the vertical line test, but for it to pass the vertical line test, we have to restrict the domain, meaning we either only need to consider 1/2 of our original graph where x is a positive, or we have to consider 1/2 of our graph where x is a negative. So in practice, what that will look like is, if we consider this portion of our original graph, right, it means that its inverse will be this portion here, of which that portion will pass the vertical line test. If we consider this portion of our original graph, it means that our inverse will be this portion of over here, which will also pass the vertical line test. So if they say it here, write down how you will restrict the domain such that the inverse of this graph is a function. You're literally going to say the following words, right? You're literally going to say restrict the domain of f of x to where x is bigger or equal to 0, or where x is smaller or equal to 0, right? you're going to restrict the domain of f of x to x is bigger than 0, bigger or equal to 0, or x is smaller or equal to 0. That's how you are going to restrict your domain. And if you check, this is a 1-mark question. 8.3.3 says, determine the equation of the inverse for which the inverse is smaller than 0. Write down your answer in the form y is equal to that. Okay, so here you have to be careful, because the inverse that they're referring to, the y values have to be smaller or equal to 0. So it means they want this portion of your inverse here. So you're going to have to be careful when you give an answer for that. You see, but let's just get the inverse first before we overcomplicate a simple question. So getting the inverse of 8 of our graph here, right? Remember, f of x looks like this, negative 6x squared. So logically, it's starting off as y is equal to negative 6x squared. So inverse, you have to make x y, and then you have to make y an x. So here x becomes y, and then y becomes x. Solving for y here, you're going to divide both sides by negative 6, and then you're going to have y squared. Don't worry about how you have what you call a negative value over there, and now you're going to have to put that negative value in a square root. The moment you're going to have to put that negative value in a square root, you have to do what we call restricting the domain, which is what we're going to explain right now. So the next step, you're going to have to square root here and there. However, the moment you get your answer, y is equal to negative x over 6, you have to specify here that x has to be smaller or equal to 0. This has to be there for you to get all your marks. You see, because this is saying that you're only considering the inverse where your x values are below 0, because as long as your x number here is a negative, this expression will always yield numbers that make sense. Okay, so in this situation though, this is where things get obviously a bit tricky, because they say determine the inverse for the inverse. Write down your answer in the form y is equal to that. Okay, yeah, so that's going to be our answer. The only funny thing is, I'm thinking to myself, our inverse here has negative y values, and this equation here will always be popping out positive y values, because if you put a negative there, let's say negative 1, yeah, this is, let's look at this one more time. So without overcomplicating anything, right, remember our inverse function looks like this, you see. So meaning, as you're subbing in your negative x values, you need to remember that your equation, right, your answers, they'll always come out as plus or minus. So here we have to put plus or minus, you see. But then your final answer here, you have to say therefore y is equal to minus square root of negative x over 6, where x is smaller or equal to 0. This is the piece of information I'd left out, because anytime you put something under square root, you have to put plus or minus there, and then you have to also keep this there for this to be valid. Perfect. Let's move on to the next question, which is question number 7. Question number 7. Here we are. It says, Mary's grandparents deposited 5,000 rand into a savings account, right, on the day that she was born. Wow. The account pays interest at a rate of 6.8% per annum, compounded quarterly. Calculate the accumulated amount in the account on Mary's 16th birthday. So this looks like a straightforward financial maths question, right? Because firstly, we are putting money into an account. every single month, right? So we're gonna have to say F. No. Deposit. Oh, they just left it there. They didn't say anything about monthly installments. So we're gonna need to use our compound interest formula. So P is 5,000 because that's the original amount. Interest, they told us that it is 6.8% per annum compounded quarterly, so we have to divide this by 4. Our value of n is always our years multiplied by the compound effect. So technically on a 16th birthday, that would be 16 years times 4. And then moving on, we have to just put all this information into our formula sheet. Into our calculator. So for 3 easy marks, we're going to say here A is equal to 5,000, 1 plus interest, 6.8% over 4. All of this, 16 times 4, that's 64. This in our calculator. Let's see what this gives us, right? In our calculator, this is giving us a total of 14,706.56. Okay, perfect. Very easy 3-mark question here. We didn't even have to struggle because it is what it is. Moving on. After, it says here, right, after 4 years, the value of a printer was half its original value. Determine the rate at which the value of the printer depreciated over this period if depreciation was calculated according to a straight line method. A straight line method means simple interest, meaning it's P 1 minus I times N. Just write a bit better. P 1 minus I times N. Now the original value we don't know, so you can label that as X. After 4 years, it is a quarter of X. That's what they said. No, half. Goodness, come on, bruh. Okay, started as X, now it's half of X. And then the rate of depreciation is what we're looking for, so we have to work out I. And then the number of years, it's 4. So working this out, you're going to divide both sides by X. Dividing both sides by X, you're going to have X cancel out on both sides. You're just going to have a half here equal to 1 minus 4i. The 4i, you can take it to the one side, the half you can take it to the other side. Divide both sides by 4. I here, it's going to be equal to 1 over 8. And this as a percentage, you have to times by 100. You see? So, you know that your value of I, right, if you're obviously going to times that by 100, this is giving you, it looks like, what percentage is this now in the calculator? Let's just put that in the calculator. This is 12.5%. You see? So this is going to be equal to 12.5%. Very simple marks. We can put there per annum, and then we can move on to the next question. This was out of 2. Perfect. And then it says here, Tsepo was granted a loan of 100,000 on the 1st of March 2022 at an interest rate of 13.5% per annum compounded monthly. Tsepo agreed to repay the loan over 5 years in monthly installments of this amount starting 1 April 2022. So no payments have been missed here because the first payment is due only 1 month after the loan is granted anyways. So this is clearly a normal basic P formula question, or rather calculate the total interest that he will pay over 5 years. Okay, so what we're gonna do here is let's work out the value of P. No. we're going to work out how much he's going to pay over the months, because remember, this is how much, logically speaking. Let's see, this is not the type of question you want to take for granted, right? It says your Tsepo has been granted this loan, blah 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 blah. Calculate the total interest you will pay over the 5 years. Well, funny enough, you don't want to think to yourself you're just going to say this amount times the number of months, and then you just subtract 100,000, because remember, the final payment on this loan will not be the full 2,398, or will it? We can easily assume that it will be, but yeah, it just seems a bit off to do that, because remember, we are definitely used to a situation where we are always needing to work out the final payment on a loan and all that. But since this is more of like a 2-mark question, you don't want to overthink it too much in that regard, you see. So all you're going to have to do in this situation, that firstly, in a space of 2022, 5 years later, that's up into 2027, so it's just 5 years, right? 5 years, each of those years he is going to be paying every month, so that's going to be 60 months that he's paying, and he's going to be paying 2,398 times 60. In the calculator, let's see there, this is giving us 138,058.8. So you're going to take that amount and you're going to obviously subtract the original 100,000 that he borrowed, right? This is going to give us 38,058.8. But they said calculate the total interest. Oh yeah, we don't have to get it as a percentage or anything. That's the total interest that he paid over the 5 years. 7.3.2. What does 7.3.2 ask us? It says Tsepo paid 22,398, right? His monthly installment and an additional 20,000 on March 2024 into the loan account. He continues to pay the original monthly installment thereafter. How many months earlier will Tsepo repay the loan? Okay, so this is a question where what you're going to have to do is, firstly, from March 2022 until March 2024, this is a total of 2 years, you see. So you need to find out the balance on the loan after 2 years, you see. So 2 years times 12, this is 24 months. Okay, so we need to find out the balance on the loan after 24 months. So to get the balance on the loan after 24 months, this is what you need to do. So there's a formula: balance after 24 months. This is what you do. Your balance will always be equal to A minus F. So your value of A is a compound interest formula. Your value of F is the future value annuities formula. So in these two formulas, your value of P is your initial loan, your interest rate we know, the number of years we know, but it's 24 here that you're gonna have to put as a value of N. So in practice, right, your balance after 24 months, you're gonna have to say 100,000 here, 1 plus the interest rate. They told us it was 13.5% compounded monthly, and then this is 24. This entire value you have to subtract 22,398 and then should have given myself some space here, 13.5% over 12, close the bracket, the whole thing over the interest, but you have to time minus the one there at the top. Okay, so let's put this, I'm going to put all this in the calculator bit by bit, right? I'm going to put all this in the calculator bit by bit. Now, the logic behind what we're doing is, well, we first need to work out how much is owed after the 2 years. And then after those 2 years, we're going to deduct the loan amount that he paid, which is the 23,000 something. And then we're going to have a new loan amount. That new loan amount, we are then going to carry on and see how long it will take him to pay that off. Okay, so let's carry on. So carrying on, right, let's see what our calculator can give us for this value and this value. So in the calculator, all I did was I've put in this value in the calculator, right, to the power of 24. Because of the compound interest formula, it gave me this value without simplifying. And then here we're minusing this f section of the formula, so we're putting our value of x, interest, exponent 24 minus 1, interest at the bottom, give us this long number here. So this value minus this value gives us the balance after 24 months. So now that we know the balance after the first 24 months, what we're going to need to do is we're going to need to take this amount here, right, and then we're going to need to subtract the 20, technically we're going to need to subtract the 23,000, no, the 22,398 amount that he made payment of. So this amount here, we're going to have to subtract 22,300.98. When we make that subtraction, we are going to be left with the following. It's going to be 44,504 point, this is a decimal. So remember, we're not deducting our, what are we not doing? We are not, we're not simplifying, because this is not the final answer, you see. So what this is telling us is that after this 24 months, right, this amount is what was owed, and then he paid this 22,398, and then he says here he paid this amount, his monthly installment, and an additional 22,000 and an additional 20,000 on the 20th, on the 1st of March into the loan account. He then continues to pay his the original monthly installment thereafter. How many months earlier will Tsepo repay the loan? So what this means is, from here, right, he continues to pay off his loan. So this is the loan that is now paying off. Now, logically speaking, 24 months have passed, right? This is what he owed. And then he made this payment, right? So if you think about it nicely, out of the 60 payments that he was going to make, 24 have already been made, right? And this one is technically the 25th payment, because here after 24 payments, his 25th payment is this amount. So meaning he only has a total of 35 payments that he needs to make. So from here you need to understand that this is the new amount that he is now owing, right? And this amount that he is now owing, he obviously needs to pay this off after a certain amount of months. So if you think of our P formula, right, P formula says x 1 minus 1 plus I to the power of negative n, the whole thing over I. What we know is this is our new P value. Our monthly installment still stays the same, the interest still stays the same, but the value of n is what's different. So let's simplify this and isolate n first. So normally what I do is you can multiply both sides by I. You can have pi is equal to x 1 minus 1 plus I to the power of negative n. Divide both sides by x. You can have this big bracket left on this side. And then what I like to do is this here that has a negative, right? Negative this bracket, I like to take it to the left hand side so that it becomes a positive. And then this pi over x, I take it to this side. Then it becomes a negative, you see. And then since we're isolating n is the exponent. So you can say log, the base of the exponent was this 1i here. And then this all has to be in brackets, 1 minus pi over x, close bracket. If you divide both sides by a negative, this would be a plus, this would be a negative. So in this formula, that's where I'm going to put everything in the calculator. So I don't want to flip a whole new page, so let me just write next to it here. Okay, so in our log equation, n is going to be equal to log, the value of I is 0.135 over 12, and then in our big bracket 1 minus, our p value is this long number here, so I'm just going to write 44504.218. in the calculator I'll remember to put everything. That number is also being multiplied by the interest over 12, right? And that whole value is over x, which is 2300.98. And then we close that bracket. So then there's a minus here. This entire value here, we are going to put all that in the calculator. So let's see what this big value gives us in the calculator. In the calculator we're getting the 22 or 21.93, which is approximately equal to 22 months. So the question in itself had said how many months earlier will Tsepo repay the loan. So technically 24 plus 22 months, it means that Tsepo is going to only pay the loan off in a total of 44 months, you see, of which 60 minus the 44 gives you how many months earlier that Tsepo is going to pay off this loan. So we have 60 months minus 22 minus the 24, or rather no after the 24 months, right, he was left with 36 months. Of these 36 months, he only paid it off in 22 months, you see. So 36 minus the 22, this is a deficit of 14 months. So he's going to pay it off 14 months earlier. There you go. So without overcomplicating anything, let's move on to the next question. Question number 6. Here we are in this 2024 November grade 12 paper 1 exam. Now everything that we've been explaining, right, you can get detailed tutorials on the entire syllabus on our course website at courses.brightyoungbrains.co.za. Now all this being said, This question says, in the diagram, the graph of f of x is drawn. That's just a parabola, as we can see there. And then they said there, G is a straight line, yes. F of x and the straight line are drawn. C is a point of intersection of f and G. EH is a parallel line drawn, or is a line parallel to the y-axis, with E a point on F, H is a point on G. Very, very basic question, I can see. Calculate the coordinates of B, the turning point of F. It doesn't get easier than that, because if you're going to get the coordinates of B, which is the turning point of F, the first thing that you obviously need to consider is the fact that you have the equation of the function anyways, you see. So the equation of your function, you're gonna put the negative x squared plus 4x plus 5, right? And then to get the turning point, as we always say, you're just gonna get your first derivative and you're gonna make it equal to 0. So your first derivative equal to 0, you can have 2x equal to 4 divided by 2 on both sides. You can have x is equal to 2. That makes sense because look, there's an x value of 3 there, so somewhere here should be a 2. That's the x value of the turning point. The y value of the turning point, we will get it by throwing in 2 into the equation of f, you see, like that. And then here you can have negative 4 plus 8 plus 5. So this is going to give you 13. Negative 14 plus 13, that's going to give you positive 9, is it not? Because that's like 13 minus 4, that is a 9. And that makes sense, because if this is a 8, this can easily be a 9. So when you're done, don't forget to make sure that you put your answer like that, so that you can see, or you can show them that you got B. The next question is out of another 3 marks. They said show that the equation of the graph, or rather show that the equation of the line through A and C is given by this equation. So the equation of the straight line. Wow. Anyways, as basic is this question. So I think that's the benefit. Well, I'm not saying when you write your exams you should go from back to front, but it looks like going from back to front has its benefits, you know. You start hard and then things end up being easier, as we can see. But carrying on from here, the gradient of this graph, we can get it how? Well, firstly, we only have one coordinate that the graph passes through. We may be thinking to ourselves, is there a way we can get another equation, or another coordinate rather? And it's a 3-mark question, so you don't overthink anything. And yes, we can get this coordinate because it's also an x-intercept of the parabola. So let's just get the one x-intercept of our parabola, because if you get it, you can get the gradient of our straight line graph. So without overthinking anything, right, let's just take our graph of f and then solve for x there, so that we can get our, what can we get? So that we can get our x-intercepts, you see. So doing that, let's see what we will get here. If you're going to, the one thing I'm thinking of doing is, well, I always just say it's easier to just use the quadratic formula, because the quadratic formula, it at least allows you to make sure that your answers are as accurate as possible, because obviously there are ways that you can easily just make silly mistakes, and we always want to try our best to avoid making silly mistakes. So let me just put all this into the quadratic formula and then see what we end up with, obviously. So let me write down the quadratic formula first and see what we get, right? So let's see here. Our quadratic formula says x is equal to, what do we have there? X is equal to minus b plus minus b squared. Wow, Levi, such a, do you really hate writing nicely that much? X is equal to minus b plus minus b squared minus 4ac 16. There's something wrong here. No, it's fine, because at least this one is going to be a plus. So all this in the calculator, we're going to get our x values as follows. Okay, so our x values, you're going to get -1, or the other one is 5, but obviously we want this one here, the one that's a -1. The 5 can go jump. So since we now have at least one coordinate that the graph passes through, right, y minus y1 is equal to m x minus x1, and then our gradient, we don't yet have it, so we cannot yet use this. Let's get our gradient using our gradient formula. But here we know that our coordinate of a is just going to be -1 and 0, and then our coordinate of c, we have it's 3 and 8. So using our gradient formula, we can easily just put the y2 minus y1, x2 minus x1, right? And then we're gonna have the 8 minus 0, so 8 minus 0, 3 minus -1. This is going to be 8/4, which is a 2. Gradient is a 2. Perfect. So here we can say y minus 8, 2, and then x minus 3, 2x minus 6, and then we're gonna have here 2x -6 plus 8. It's +2, and then this you're just gonna write it as g of x, 2x plus 2, which is what they want us to have anyways. Moving on to 6.3, right? 6.3 says calculate, I'm actually get a new page, calculate the maximum length of EH for which f of x is above g of x. So logically speaking, this is the part where f of x is above g of x. They want you to work out the maximum length of EH. That's very, very simple to do. All you're going to have to do is you need to get the distance equation of EH, and a distance equation of EH, you're simply going to say the equation of f minus the equation of g. This here is the equation of EH in terms of x. So let me write it nicely. EH in terms of x, you're going to take the equation of f, which in this case we know it's -x squared plus 4x plus 5, and then you're going to have to subtract g of x. Subtracting g of x, you can have this, because you minus and you minus. Simplifying this, you can have -x squared. So far we're going to have 2x and then plus 3. So this is an equation of the length of EH. Once you have an equation of the length of EH, what you need to do with that equation, since they asked for the maximum, remember we always say anytime they ask for the maximum of anything, always differentiate that equation and then make it equal to 0. You see, so no, that's just a 2. We've differentiated it. Now we make it equal to a 0. -2x plus 2. 2x goes to the other side. X here is a 1. So your x value is a 1. That's the x value that will give you the maximum length. But the x value that gives the maximum length is a 1. The maximum length itself, you have to put a 1 into the equation. You see? So into this equation you have to put a 1. put a 2 there. 1 plus 3. This is like minus 1 plus 2 plus 3. That's like 5 minus 1. That's a 4. So the maximum length there is a 4. There you go. It's just a 4. But I seem to have, yeah, the maximum length is just a 4. So without overcomplicating it, right, let's move on to the next question. 6.4 says, given that k of x is equal to that whole expression over there, determine the value of m such that g is a tangent to k. Okay, let's read that again. K of x is the graph of f after it has been moved a certain amount of units to the right or left. Once that graph of f was moved, right, they said determine the value of m such that g is a tangent to k. So the logic behind that is that the graph of f is being moved, and the only direction that the graph of f can be moved for it to be a tangent to the graph of g is if it's moved to the right. So logically, if this is moved to the right, somewhere here, your graph of f will be touching your straight line such that it is a tangent to that curve. So they'll meet somewhere. We're not saying they'll meet at C exactly. We're just saying that's the image that you need to think of. So for the tangent to be a curve, so for the graph of G to be a tangent to the curve, we need to think of a scenario where this new graph has a gradient of 2, or rather this is the equation of the new graph, right? Let's just write it out first. K of x is equal to the following, right? Let me just write out the equation of k first, because that's obviously the first important piece of information that is essential. So the equation of k, we have to write there negative x squared minus 2mx minus m squared plus 4x plus 4m plus 5. This question, we have to be very careful when we think of the logic behind this question. So first and foremost, for this line, for this curve here, to have G as a tangent, the link is the gradient of 2. So the question, let's see what it is asking us. Given this whole thing here, determine the value of m such that G is a tangent to k. So m is the amount of units that the graph will be shifted, but we don't have to worry too much about m. All we need to worry about is what can we do with this equation of k to link it with the gradient of 2. So if you differentiate the equation of k, right, your first derivative will be giving you a gradient equation of k. That gradient equation, we can throw in our gradient value as 2, and then from there we can carry on. But then the unfortunate thing is that in a scenario like that, your x value, we won't have anything to put in there. But what we know is that your tangent and your curve, they share a gradient, and then they also share a coordinate. So before we overthink anything, right, this is a 5-mark question. So let's start off by doing what we have just spoken about now, and then we'll cross that bridge when we get there. So the first derivative, right, it is clearly going to be negative 2x. If you differentiate this, it's going to be 1 times 2m. So that's 2m over there, and then the x is just going to go away. This technically qualifies as a constant. So if you differentiate it, it falls away. Here you can have 1 times 4. You can have your 4 here. This counts as a constant. This counts as a constant. So when you get your first derivative, this is what you're going to end up with. And we can just take one glance at the question to see if we've not made any mistakes. We haven't. So in your first derivative, the gradient, you know that the gradient is at 2 where this curve meets your tangent. So let's see what we get if you put a 2 there. Now, funny enough, having to have done all this, we can see that x would be an x value where the tangent and the curve meet. So let's see what happens if you isolate x. If you isolate x here, right, you're going to have 2x here, then you're going to have negative 2m. 4 minus 2, that's just going to give you a 2. Divide everything by 2, you can have x is equal to negative m plus 1. So this is telling you an x value where your tangent and your curve meet. You see, this is the x value where your tangent and your curve meet. What you do know is that the tangent and the curve, they share a coordinate. So what you can do is you can actually throw this x value into this equation, but then we don't have a specific y value where that tangent will be meeting our curve. For 5 marks, I feel like we're overdoing it, to be honest. So let's see, g negative m plus 1 is equal to 2 negative m plus 1 plus 2. This simplified, you're gonna have negative 2m plus 2 plus 2. This is negative 2m plus 4. So without overthinking it, right, let's see what we can do here. So for 5 marks, it does seem as though I'm going too far, but this is my logic behind the next thing we're gonna do. So you see here, our problem is that we don't know the y value where our tangent and our curve meet. But the logic that we can use is that our gradient of 2 for our original graph, we don't know where it is, right? But the gradient of 2 could easily be maybe somewhere here. We don't know what that y value is, right? Where this gradient is at 2 there, but we can find out. Because logically, where the gradient is at 2 here, if you move this graph horizontally, the gradient will still be at 2 somewhere there, and its y value where that gradient is at 2 will still just remain the same. So we can work out the y value somewhere here where the gradient is at 2, and then we can make use of that y value for when our graph has been shifted. So let's take a detour. Our original graph, right, let's get its first derivative. The first derivative of our original graph, right, was simply going to differentiate this equation. This is the equation of our original graph. We can also see it from the paper they gave us. Our original graph is this. So let's differentiate that equation. Differentiating it, we're going to have negative 2x and then plus 4. We want to find out in this original graph, where is the gradient equal to a 2? Because where the gradient is a 2 for the original graph, its y value where that gradient is a 2, it will just be the same as the new y value where the tangent will be meeting the curve. So okay, so here it's giving us an x value where the gradient is a 2. We can then take that x value and get the y value. So let's carry on. 2x, then 4 minus 2 is a 2 over 2. This is also a 2. X is a 1. So this is telling us that where x is a positive 1, that's where your gradient is a 2. So let's find out the y value where that is happening, right? So in our graph of f, our original graph of f, for 5 marks, I feel like I am just doing a bit too much. But the logic behind what I'm doing is the fact that if what you're doing is guaranteed to give you a mark. Just carry on until you're done. It doesn't make sense for you to pause and think of a shorter way when what you're doing is already giving you an answer. So let's see here. Your final answer here, this is 9 minus 1, that's 8. Okay, that's very, very coincidental. Very coincidental. So what we now know is that our y value is a positive 8, where the gradient is a 2. So here we can throw in a y value of 8, and then here we're going to have here negative positive 2, and then 4 minus 8, and then from here we're obviously going to end up with negative 4 to m divided by 2 on both sides. Our m is equal to negative 2. So this is telling us that our graph has to be moved 2 units to the right for that new graph to be a curve that's a tangent to the graph of g. M is equal to negative 2. So I suggest you look at this video or this specific question. You can go back to the top, listen to the words, and then everything should make sense. Let's move on to question number 5. Question number 5, it says here, sketched below is the graph of f, right? It's a hyperbola. They say that the graph of f having the domain negative infinity all the way to positive infinity, where your asymptote is at positive 1. Then it says that the graph of f cuts the y-axis at 0 coordinate 1. Then it says your line of symmetry, you have been given an equation. That's an essential piece of information. One thing we also know is that your line of symmetry always passes through where your asymptotes meet. First question, they're asking us to get a value of p. P is obviously the x asymptote. So on the actual Cartesian plane, you can see this is a plus 1. But then when you put it in your equation, you have to put there a minus 1, you see. So you have to be very careful over there. So for 5.1, the first thing we're going to write down is that p is equal to minus 1. Because in the equation, you have to put the opposite of what you see on the Cartesian plane. The next question says, determine the equation of the horizontal asymptote of f. So they're logically asking for the value of q, meaning this. So to get that, we can easily use the equation of the straight line. Remember, they gave us the equation of the straight line. They said it is x minus 3. What we know is that the x value here is a positive 1, so we can get its x value. So if we get the y value there, so the x value is a 1 in our equation. So the coordinate, the y value is a negative 2. So the equation of that horizontal asymptote, we're going to say y is equal to negative 2, because it cuts the y-axis at negative 2. Calculate the value of a. So far in the equation of f, right? The equation of f, so far this is what we have. A, and then we have x minus 1, technically minus 2 here, because with q you take it as it is. So if you're going to get a, we need a coordinate that the graph passes through. Fortunately, we've been given this coordinate. No, this one. 0 coordinate 1. So where x is, we can put a 0. Where y is, we can put a 1. Solving for a here, you're gonna have the 2 goes to the other side. It's gonna be 1 plus 2, that's a 3. And then times both sides by a negative 1, you're gonna have negative 3, that's a. A is a negative 3. Easy marks. 5.4, right? It says, for which values of x is f of x bigger than 0? That's a very, very straightforward question. For which values of x is f of x bigger or equal to 0? So logically, for 3 marks, they're asking so little. The graph of f of x is above 0 at this point. portion over here. So we have to get the x-intercept first. Then we can say it's from this x value up until the asymptote. So we have to get the x-intercept of f. Getting the x-intercept of f in our equation of f, which we now have fully, we can just make our y value as 0. So -3 x minus 1 minus 2. The 2 goes over to the other side, and then from here we're just going to cross multiply. 1 times -3, 2 times x minus 2, that's like 2x minus 2, right? And then you're going to have -3 plus 2, that's -1, and then 2x there, divided by 2, divided by 2. X is -1/2. There you go. So it means that this x value here is a -1/2. So between -1/2 and +1/2, this is the section where your graph of f is above 0. So to answer that, you're going to say your x is an element of -1/2 up until 1. So the reason why I'm putting a square bracket there is because they say it bigger or equal to 0. So here it's equal to 0, and then afterwards it has y values that are bigger than 0 up until where x is a 1. We put a round bracket where 1 is because the graph doesn't touch the asymptote. For 2 marks, before we get those 2 marks, they said the graph f undergoes a transformation to h, where the domain and the range of g are the same as that of f. So the domain and the range stays the same. That's interesting. Then they said here the first derivative of g, so what the first derivative of h rather, or rather what you should be looking at there is, you could be thinking of it as the gradients of h, right? It says here the first derivative of h is negative on its domain. Let's see, h derived, which is the derivative of h, is negative on its domain. What do they even want to say there? But let's see, it undergoes a transformation, right? The domain and the range of h are the same as that of f. So the domain of f, we know it's just x is an element of r, but then x cannot be equal to 1. The range, we know that y is an element of r, but then y cannot be equal to -3. So this information we know. So they said the domain and the range stay the same, right? But then they said here h, the derivative of h, right, is negative on its domain. Is negative on its domain. Okay, so the first derivative, we know it refers to the gradient. So what we know about the original graph of f is that the different gradients here, all these gradients, they are positive. Yes, all these gradients, they are positive, because if you draw any tangent anywhere, the gradient will be a positive. If you draw any tangent anyway, the gradient here will also be a positive. So if they say that the derivative of h is negative on its domain, what it means is it's just going to have negative gradients everywhere. So for 5.5, firstly the domain and range stays the same, right? So your asymptote is still at +1 and at -3, but then your image is gonna have to be here, and it's gonna have to be here. You see, this is where your graph of, this is what your graph of h is gonna look like, because they said that its first derivative, all the gradients are gonna be a negative. You see, so this is what the image is gonna look like. So an image like this, you can basically say what transformation, describe a possible transformation of f, the determine possible transformation that f could have undergone to result in h. So logically you can easily say the graph was reflected about either, you can easily say it was reflected about either the x asymptote or it was reflected about the y asymptote. Either or, that will still work. So you can say here f is reflected about the x asymptote or about the y asymptote. You see, either of those two will still result in a picture that looks like this, because if you reflect this image about the the y asymptote, you'll have an image over here, and then you have an image over there. And then if you reflect it about the x asymptote, you'll have the picture over here, or the picture will be over there. So these are the two possible reflections that have occurred. Easy, 10 marks. Let's move on to question 4. Don't mind me here, I wrote -3, I meant -2. There we go. Here, yeah, -2. But anyways, everything is still 100% correct. Question 4 says, given that f of x is equal to a over a to the power of x minus 1, right? And the a is bigger than 0. B is this point, so we don't have a sketch to refer to. They then said all this information, right? B is a point on F, and then they said A is a positive number. That's essential. They said calculate the value of A for 2 marks. Very, very simple with 2 marks, because we have an incomplete equation already, so that's a place to start. We also have a coordinate that same graph passes through, so we have no shortage of information here. So where we see f of x, we're going to put -5/9. X, you're going to put a 2. Oh, this is a, excuse me, this goes to the other side, so this plus 1, that's going to give you 4/9, and then you're going to have a squared. So you're going to square it both sides. Logically, that's just going to give you plus or minus 2/3, but then a has to be positive, so a is 2/3. Well, you can write a is equal to 2/3. For those that are sentimental about put the variable first, it is what it is. 1 mark, write down the range of f. So if you're going to write down the range of f, the one thing you want to remember is that this is an equation of an exponential graph, and the asymptote is at -1, because this will always give you the asymptote. So since your a value is a positive number, right, and it's this fraction, the logic behind this fraction is that as this x value gets higher and higher and higher and higher and higher, the value of your y value here will just be getting lower and lower and lower and lower and lower. So your picture, right, which I see they are asking for in the next question over there, which we can actually do this as 2 in 1, you see, because if they want us to draw the graph and show the intercepts and the asymptotes, firstly let's put this asymptote here, right, and then the intercepts. Firstly, this won't have a x-intercept, because if you put your y as 0 and you put the 2/3 x minus 1, if this goes to the other side, you have a positive 1. Oh no, it does. I'm saying things wrong here. Logically, x here has to be a 0, because for x to be a 0, that's the only time where this value is a 1. So what you know that your graph has the x-intercept there, right? But what you do know about this particular graph is that it will look like this, and that's something you can easily see if you use the table method in your calculator. But what you can actually do for yourself is, if you put negative numbers where x is, right, in this equation, if you put negative numbers here, you will see that your values of y will be getting bigger and bigger and bigger. And then if you put positive numbers here, your values of, well, this is actually a bit strange. No. If x is a 1, this will give me 2 over 3 minus 1, which is a negative value. I'm getting confused over nothing here. Everything here is perfectly fine. This is the picture. So it means that the 4.2 range, you're just going to say that your y values are bigger than -1. You see, two birds with one stone. Sketch, range. Let's move on. Let's not overcomplicate it. 4.4 says it says it is further given that C is a point on F at y is equal to this. Determine the coordinate of the reflection of C when C is reflected about the line y is equal to x. So inverse. Okay, well, let's get the coordinate of C first, the full coordinate, because getting its inverse is as basic as basic gets, right? So it's a point on F. So fortunately we can take your equation of F, write it nicely. We have a y value, right, which is 19 over 8, 2 over 3 of x minus 1. If this goes to the other side, 19 plus 8, that's like 27 over 8, right? And then you have 2 over 3 to the power of x. Here we're going to have to use logs, right? You're going to have to say there the exponent is x, right? So log the base of the exponent, 27 over 8, like that. You see, so let's see what that gives us. So putting everything into our calculator, let's see what this gives us here. We get there, the calculator is giving us an x value of -3 in the calculator. X is equal to -3. So now you know that the coordinate of C is going to be -3 and 19 over 8. So it means the image, you have to swap around these two, because that's what inverse does. Inverse just swaps around the x and the y values, you see, without even overthinking it. So that's an easy question. Let's move on to question 3, because remember we're working backwards, you see. Let's move on to question 3. Question 3, it says here, a circle with a radius of 6 is drawn. A second smaller circle is drawn through the center of the first circle and also touches the first circle internally, as shown in the diagram. A third circle is drawn through the center of the second circle and touches the second circle internally. The process of drawing circles continues and forms a geometric pattern. Okay. 3.1 says, write down the radius of the third circle. Well, this is not rocket science, because logically, if the radius here, right, the first one is a 6, it means that the second one, the radius is halved, so that's a 3. Then the other one here is just 3 over 2. So write down the radius of the third circle. It's just 3 over 2. So you're going to say 6 divided by 2 divided by 2 again. You're just going to have 3 over 2. Nothing too complicated about that question. It's actually quite straightforward. Calculate the sum of the areas of the first 10 circles. Okay, so if you're going to calculate the sum of the areas of the first 10 circles, all you have to do is write a sequence of the areas, you see. So area number 1 will be half, it's pi r squared. That's the area of a circle, pi r squared. The first circle, pi r squared, right? The second one, pi r squared again. The third one, pi r squared again, going on and on and on. But the actual figures, the first circle, right, its radius is a 6. The next one, its radius is a 3. The next one, its radius is a 3 over 2. So the value of your areas here, you can clearly see it's just 36 pi, 9 pi, 9 over 4 pi. So this is a sequence. In this sequence, you want to work out the sum of the first 10 terms, right? So to get the sum of the first 10 terms in a geometric sequence, right, your SN formula has to be A. You can put the 1 minus r to the power of n over 1 minus r, since our value of r is clearly going to be smaller than 1. So to get a value of r, this divided by this, it will just give us 9 over 36, of which 9 over 36 simplified, this is just a quarter. And then that's our value of r, right? R is a quarter. So n is a 10, a is 36 pi, and then that's it. Let's put values into our calculator. Sum of the first 10 terms, you're going to have a as 36 pi, r is a quarter, n is a 10, 1 minus a quarter, right? So let's put all this in the calculator and see what our answer comes out as, right? So looking at this nicely, right, let's just put the stuff in the calculator correctly so we don't make any silly mistakes. Put that there, 36 pi, and then we have the to the power of 10, and then we have our denominator, and then let's see, there we have, yeah, so our final answer in this question, if everything is correct, you should get the let's see what we should get. You should get the 150.80 if you round it off to 2 decimal places, because your answer is actually 79, but then rounding off to 2 decimal places, 80. And then since you're dealing with centimeters, you can put the centimeters squared if you want, but fortunately this is not physics, so you can get away with not putting units there. 3.2, let's go to 3.2, right? No, 3.3. This was 3.2. 3.3 says, which circle has a diameter of 3 over 128? So you can also just get a sequence of diameters. So the first diameter is a 12, the second diameter is a 6, and then the other diameter is a 3. So obviously in this sequence, your value of r is just a half. You see, so your sequence formula is going to be a, it's going to be a is a 12, r is a half, n is n. So this is your general term. If you're going to find out which diameter is equivalent to 3 over 128, you can just put 123 over 128 in there, 12, and then if you're going to work out a value of n here, just be careful. Getting a value of n, you can divide both sides by 12 first. You're going to have, or rather what I normally like to do is I like to isolate n before even doing anything. So to isolate n there, you can firstly divide both sides by a, right? And then we can get logs. So n minus 1 is equal to log. The base is going to be r, and then T n over a is going to be here. the 1 goes to the other side. So our value of n, it's a matter of just putting this information in the calculator. But let's put the values first. Log r is a half, tn is 3 over 128 over 12. This normally just helps to not find yourself simplifying before your final answer, because normally your final answer, you don't want it to be rounded off or anything of the sort, you see. So let's see here, if you put everything in your calculator, your value of n there, it should come out as 10. There you go. The 10th circle is the one that will have the diameter 3 over 128. So that's question 3. We can move on to question number 2. Question number 2 says the first term of an arithmetic series is 7. The common difference of this series is 5, and the series contains 20 terms. Calculate the sum of the series. Very basic, very straightforward, right? Our SN formula for an arithmetic sequence, you can get that in the formula sheet, and 3 marks. There we go. We have been given everything. It's just too obvious. They said the first term is a 7. You're adding up 20 terms, so S20. N is 20. A is the first term. They told us it's a 7. N is 20. Your common difference, they literally told you it's a 5. This is one of those questions where getting a question like this wrong, yeah, it's just wrong to do that, you know. Like, this is the type of a question where they are just trying to make sure you don't get a 0, you see. So let's put everything in the calculator, see what it gives us. This is giving us some of the first 20 terms. This is just 1090. Moving on, 2.1.2, right? They said there the original arithmetic series is extended to 75 terms. The sum of these 75 terms is 14,400, and 14,400, that's it. Then it says, using sigma notation, write down an equation for the sum of the terms added to the original series. Okay, the original arithmetic is extended to 75 terms. The sum of these 75 terms is this much. Using sigma notation, write down an equation for the sum of the terms added to the original series. An equation for the sum of the terms added to the original series. Using the sigma notation, write down an equation. So what that means is, firstly, your sigma expression looks like this. Technically, the first 10, 20 terms, you have accounted for those. They said here the series is extended to 75 terms. The sum of these 75 terms is 14,400. Okay, so using sigma notation, write an equation for the sum of the terms added to the original series. So 75 minus 20, you added 55 terms, right? Starting from the 21st term. So here you're gonna say n is equal to 21. You're gonna go up until 75. Your general term is what you're gonna put over here. But to clarify before I carry on, right, all you're trying to say is that in your sigma expression, you're gonna add terms from the 21st term up until term number 75, right? Your general term will still just be a basic arithmetic. Oh no, I'm writing there and I'm not seeing that I'm writing where I already have something next to that. So your general term here, a is the first term, so that's sorted. D is 5. So your general term here looks like this: 5n and then plus 2. This is your general term, so that's what you're going to put over here: 5n plus 2. So this expression tells you you're adding up terms from term number 21 up until term number 75, right? This is your general term to do that. All these terms added up should give you 14,400 minus 1090. So this is giving us, what is that giving us over there? Let's just check that in the calculator over there. So all this here, this is giving us, this is obviously gonna be 13,100, no, 13,310, 13,310, like that. This is what you're gonna need to write as your sigma expression. So moving on, let's just go to 2.2. 2.2 says the equation or the sequence of the first differences of a quadratic pattern is this. This is the sequence of first differences. So before you even do anything, right, a sequence of first differences, this is what it means. So from here, let's just write out 2.1 first. So the first thing you want to understand is that we don't know what the original quadratic sequence looks like. However, the sequence of first differences, the difference between this number and this number is a 1. Between this one and this one, it's a 3. Between this one and this one, it's a 5. That's what they're telling us by telling us that the sequence of first differences is 1, 3, and 5. Then they say it here, if T99 of this quadratic pattern is 9,632, calculate the value of T98. Okay, that escalated a bit quickly. But okay, so logically speaking, this is T1, right? T2, T3, and T4, going on and on and on. I wish I had not put this here, because now I don't have somewhere to write nicely. Ah, man. Okay, let's just maybe put it here. So this is T1, T2, T3, and T4 going onwards. What you want to understand is that T98 is somewhere here. And then after T98, you have T99, obviously. Logically, between T98 and T99, you also have a number that is in this sequence of first differences, right? Now, the logic that you want to remember before you think of what they're asking us to do here is term number 1 in this sequence is the difference between 1 and 2. Term number 2 is the difference between 2 and 3. Term number 3 is the difference between 3 and 4. So logically, term number 98 in our sequence of first differences is the difference between 98 and 99. So if they told us that term number 99 is equal to 9,632, these are what they told us, right? With that information, they said here you should calculate T number 99. So all you're going to have to do is, in this sequence of first differences, just work out T number 98. You see, because if you work out T number 98 here, you can just say x plus this value gives you that number. So in our sequence of first differences, let's get a general term, right? A plus n minus 1d, and then a is a 1, n, you're gonna put 98 there because you want to find out term number 98. The common difference here is just a 2. You see, so in the calculator, let's see what we get here, right? Let's just see there in the calculator, T number 98, let's just write this a bit nicer. This is like 1 plus 97 times 2, right? 97 times 2. Ooh, why do I write so bad, you know? Like, why can't I just have a nice handwriting, you know? This is 194. Yeah. Plus 1, that's 195. Okay, so let's put this in the calculator nicely. See what it gives us, right? So in the calculator, this is giving us 198. Why do I have to put wow, bruh, come on, my brain is not braining. But term number 98 in this sequence is 195. So all you're gonna say is therefore x, you can label this with x plus 195 is equal to 9632. So that's 9437 in the calculator if this goes to the other side, you see. So we can say here T98 in quadratic sequence. There you go. 2.2.1 says it is further given that the third term of the quadratic pattern is 32. Determine the general term, okay, of the quadratic pattern. That's interesting because we said that we don't know what the original sequence looks like, right? But then we said, they told us these are the first differences. They said the third term is 32. So we can actually just work backwards, you see. 32 minus 3 gives us 29. Minus 1 gives us 28. So this is our sequence, 32 plus 5. That will give us 37. All we need now is to get the general term. This is equal to 2a, this is equal to 3a plus b, and then this is equal to a plus b plus c. Very straightforward. They're only giving us 5 marks because of all the writing that we're doing here, not necessarily because what we're doing is anything difficult, you see. B1 minus 3 gives us -2, and then here a plus b and c, we have a and b already, so we can just drop that there. This is -1, and then we're gonna have here 28 plus 1, that's 29. So our general term, we're gonna say n squared minus 2n plus 29. There we go. Very, very straightforward question. We don't even need to struggle with questions like these, right? But let's move on now to question number 1, because remember, the logic behind all we were doing here is that we were working backwards. So let's do question number 1. Okay, question number 1, here we are. Solving for x, that's as basic gets, but you can see the logic why I made us go through the back first and then the front, because it's easier to go through the easier questions when your energy might be a bit lesser. 2 marks, easy. 1.1.2 says we need to get the answer to that expression, but then we should give our answer to 2 decimal places. Well, putting all this into our calculator, before we can do that, we have to put this in quadratic format. You see, x is equal to minus b plus minus b squared minus 4ac. A is a 2. B is a -4. B is a -4 here squared. A value is a 2. C value is a 1. These are obviously like the questions that prevent a majority of individuals from getting a 0. So we appreciate questions like these, you see, because they help. x is either equal to 1.71 if you round off, or it's equal to 0.29 if you round off. Moving on, nothing to look at here. 1.1.3, right? It's as basic gets. It is x squared minus 2x minus 3. Where is this bigger than 0? So normally the way I answer these questions is, firstly I solve for x, right? I solve for x first, and then I work out where is the graph above 0, because logically this is a graph that's a smiling parabola. Let's firstly find out how many x-intercepts it has. So in the calculator, or rather by factorization, x is a 3 here, or x is a -1. So what you know is that your one x-intercept is a 3, the other one is a -1. The question is asking, where is the graph above 0? It's above 0 over here and there. This is a section where x is bigger than 3 or x is smaller than -1. You see, very straightforward questions, nothing to really, write home about. 1.1.4, it's a exponential, it's exponents that we have to deal with, which is okay, but nothing major there. We just have to use the K method, because look here, you have 2 to the power of x squared. Here you have 2 to the power of x multiplied by 2 to the power of 2. So logically you can put 2 to the power of x here squared, right? And then here you can put a 4 in front of your other 2 to the power of x minus 32. And then if you look nicely, if you let your k be equal to 2 to the power of x, you have k squared minus 4k minus 32 equals to 0, of which this you can factorize. You see, you can easily factorize this. It's not even gonna take you time to factorize this. 8 and 4, yeah, 8 and 4. So your two factors here, you're gonna have to put 8 and 4, but then to get a -32, it has to be -8 times plus times +4, because -8 plus 4 gives you this -4 here. So k is equal to 8, or k is equal to -4. So you can say therefore 2 to the power of x is 8, or 2 to the power of x is -4. This cannot yield any valid answers, so your value of x is just 3. Moving on, let's carry on. We're blazing through this section as we should. You see, the next question, you have a square root of -2x plus 4 minus x equal to 2. Everything goes to one side first, excluding the section that's in the square root. You're gonna square both sides, so this square root goes away. -2x plus 4, you have 2 plus x, 2 plus x, and then you're gonna have your 4 plus 2x plus 2x, that's a 4x, and then you're gonna have your everything on one side, right? So that's like x squared. 4 plus 2, that's like 6x. 4 minus 4, that's a 0. And then if you factorize this, you have 6 here. X is a 0, or x is a -6. My guy, where are you getting the 1 from? There you go. So we don't want to waste time on these trivial questions, right? Our goal is to do the harder questions. That's why we started from the bottom, and now we're here. 1.2, you have what do you have there? You have a simultaneous equation question. Simultaneous equations questions are as basic as it gets. We can isolate y here. You're gonna have 3 minus 2x, and then you can put that in this equation. So doing that, you're gonna have 3 minus 2x squared. You can have x here, 3 minus 2x equal to 2. Here you're gonna have 9 times 9, and then you're gonna have negative 12x, and then positive 4x squared. Then here you're gonna have 3x minus 2x squared minus 2 equal to 0. Yeah, we're not wasting any time on easy peasy questions. Moving on, everything simplified. 4 minus the 2 gives you a 2, and then logically you're gonna have negative 12 plus 3, that's negative 9, and then what else? 9 minus 2, that's a 7. Okay, so this, we're obviously gonna just need to put it in the calculator using our quadratic formula as we always do. So let's see here. We're gonna have here x is equal to minus b plus minus b squared minus 4ac over 2a. X is gonna be minus b plus minus b squared minus 4ac. A is a 2. So what are our two answers here in the calculator? In the calculator, we are getting the x is either a 1 or x is equal to 7 over 2. So that's giving us x values, right? To get the y values, we can just put that into the original equation up there, either this one or that one, it won't matter. So here we're gonna have 3 minus 2 times 1, which is y is a 1, or y is equal to 3 minus 2 times 7 over 2. This, what is that gonna give us? It's gonna give us the number 4, minus 4 actually, you see. So we have all our answers. Not too bad. Let's move on to the last question in this exam. Funny enough, it's this 3-mark question here. Doesn't seem too bad, but let's carry on. It says, consider the product. This question looks familiar. I'm pretty sure I've done a question like this multiple times. But it says here, consider the product of this expression going on and on and on. Each factor in the product is in the form 1 plus 1 over n, where n is bigger than 2, yes? Bigger or equal to 2. For 3 marks, it says, determine all the values of n for which the product will be an integer value. For 3 marks, we don't want to panic, obviously. Yeah, we don't want to panic, obviously. But let's see again. Consider this equation. Consider this product going on and on and on. Determine all the values of n for which the product will be an integer value. So for the product to be an integer value, it means that it needs to be a number that does not have decimals. But before we worry too much about that, let's see what's happening here, right? This plus a half, 1 plus a half is technically 3 over 2. And then this is technically 4 over 3. And then this here is technically 5 over 4, going on and on and on. So the logic that we are seeing here is that if these are going to be multiplied by each other, the 3 will cancel this 3, the 4 will cancel this 4, and then logically the fifth number, the next number here will have a 5 with a 6 on top, going on and on and on. So essentially you will have a scenario where your product, it's actually not too far-fetched anymore what we are supposed to do. Determine all the values of n for which the product will be an integer value. Okay. So what can we do here? Well, this is the end of the exam, right? So logically, this is the type of a question. If I was starting off, I would have skipped this and would have only come back to it right at the end when I have looked at all the other questions, because it's not very straightforward. But it's out of 3, so here we are. Let's see what we can do. So I looked at this question for a few seconds. The logic here is that for your product to always be an integer, your value down here just has to be an odd number. Because look, if you're only considering these two, right, you would have had 3 over 2 times 4 over 3. The 3 would cancel the 3, you would have 4 over 2, which is a 2. If you were only considering let's say the first 4, so the logic behind what I'm saying is that as long as your value of n is an odd number, right, you will always end up with a product that's an integer. Because for example here, your value of n is not an odd number, so you are ending up with a situation where you have 3 over 2, 4 over 3, 5 over 4. You see, this number is not odd. So because this number is not odd, the product here, this will cancel this, this will cancel this. You're going to end up with 5 over 2. You see, this is not an integer, because when you simplify this, this is 2.5. So as long as your denominator is an odd number, your product will always be an integer. Because look, if you put in the next value here, right, you will end up with 2 over 3, 3 over 2, 4 over 3, 5 over 4. The next number here has to be 6 over 5. You see, this is odd. And then if you do the multiplication here, this cancels, that's a 3, this is a 2. This 3 cancels this, this cancels this, this cancels that. You're going to have 6 over 2, which is a 3, you see. So to answer this question, you're going to answer it verbally. Determine all the values of n for which the product will be an integer. You're going to need to say a should be an odd number for your product to be an integer. You see, n just needs to be an odd number, because as long as your value of n is an odd number, right, you will have, or rather we should say n should be an odd number bigger than, technically it has to be an odd number that is bigger than 2. For your product to be an integer.